How many of you know Ram Iyengar from previous events? I've come to see that he has a bit of a fan following himself. Yeah, is there anybody who does not know Ram Iyengar? Okay, couple of them. Okay, so for the benefit of the couple who have raised their hands, Ram Iyengar is a developer advocate at Cloud Foundry. He is a regular at a lot of the events that you can see that happen in Bangalore and otherwise. And he'll be. How many of you kind of try to update yourself on the latest tools that are there in the cloud native space, or we don't always get time, right? So that's why I was really looking forward to this talk wherein he's showing some of the hidden gems that are there under CNCF. And you can see how it would impact your workflow, what you can take away from it, how much of it is suited for you. So all good? I think over to you, Ram.
Thanks so much. No pressure, right? I'll apologize in advance if the slideshow doesn't go as planned, because what happened earlier today was I had to, all right. So I had to make some last minute changes. Hopefully things go off. Now that the AV issues are out of the way, I think it will be smooth sailing from here on forward. Earlier during the keynote, Humble reminded us about something, about how Bangalore reflects the CNCF spirit and so many other things. And the reason I'm having to repeat this is a lot of you were not here at the keynote, and those of you who were here were trying to score a few early t-shirts. But what Humble said was Bangalore is very reflective of the CNCF ecosystem, and I thought, I was thinking about that a little bit, and then I wanted to push that into my presentation somehow, because I think there's a nice story to tell. And if you know anything about Bangalore, or if you feel strongly about Bangalore, or if you've known of the Bangalore story, it's a beautiful city, right? A lot of people love Bangalore. It's the city of dreams today. I know Bombay is like the city of dreams, but there's a lot of rains, and it's not quite the startup ecosystem. So Bombay is the city of wet dreams, or no, that didn't come out right. So anyhow, Bangalore is the city of AI startup dreams, whatever. Okay, and if you look at Bangalore over the years, it's become more populated, more dense, more crowded, more things are happening. There's a lot going on in Bangalore all the time. And looking at these charts that sort of describe that growth got me thinking, I know this, I've seen this happen. This is an old version of the CNCF landscape when it could fit on a browser display window. And then much like Bangalore, the CNCF has also grown and exploded, and more projects and more people and more things to look at. And this is from a few years ago. This is the one that I updated and downloaded about 40 minutes before. And it takes a lot of patience and effort to just process all of these projects. And so there's really a story here. The CNCF is exactly like Bangalore. It's a little too crowded. Nobody knows what they're doing. And so it's very hard to identify projects that you really want to use. And for a lot of good projects, it's really hard to get that kind of critical visibility that's required. And so my session today is a little bit about how you can navigate this really crowded landscape. There's even like a jigsaw puzzle of the CNCF landscape if you're interested. But today I thought I'll take a little time because my job pays me to basically go to different places, collect t-shirts and stickers. I have a lot of time on hand. And so what I like about my job is that it allows me to experiment. It allows me to take a look at new technologies, take a look at some stuff that people are not necessarily looking at, and try it out and see if it actually works, and if the documentation actually does what it's supposed to do, and if all of the commands are easy to copy paste, and if it's an idiot-proof guide to trying a project out. And so there's a lot of projects that I have come across which I think are extremely useful, but I really had to go the extra mile to cherry pick about 5, and I ended up with 6, obviously. So I've picked a handful of projects which I think will make your workflows really good when you're in Kubernetes and if you're in the current contemporary space of things. So that's my talk today. And what's my selection criteria? Bad documentation, but also like if it's got very low number of stars or whatever. And then if it's a more sort of recent project. And the way I went about this is if you go to the CNCF GitHub repo, there's one for sandbox projects. And then this is extremely useful to learn about projects that are coming up. And so you can see a lot of things that get submitted here. And if you're bored of watching web series and if the movies that are recently released are not up to your drama standards, read through some of the comments here. Extremely interesting to see a lot of the discussion. I've said this a lot of times on different stages, but there ain't no drama like open source drama. Okay, so read through some of the projects here. You might get ideas about what people are working on, but you might also get some ideas about what they're struggling with and how you can help them. You can also enjoy a lot of like extremely heated discussions between people who are, I don't know, managing the community on the TOC, trying to submit things and things like that. So that's, again, because I don't have a social life, that's where I like to hang out during the weekends. And if you don't want to admit it, but you're like me, it's a good place to hang out. So that was how I went about selecting some of these projects. So I was just looking for projects that are, sandbox stage or submitted early, and then looking for projects that really needed a little bit of push in terms of marketing. And so the first one that I thought I'll focus on is kpack. Have people here heard of kpack? Yes? Damn, I was hoping for a no. But okay, people here have heard of kpack. That's great. Kpack, in a very short summary, is an image builder that runs on your Kubernetes cluster. And the idea is it will build images that you want to run on the cluster itself. So let me repeat that. So you have a Kubernetes cluster, and the way you get images there is through your CI/CD pipeline of some sort, Jenkins, okay, right now, but you want to be like Argo or something. So secretly, we're all Jenkins engineers who pretend to be like Argo fans. That's my opinion. But anyhow, what kpack allows you to do is it will sit within your CI system, but it will sit on your cluster and it will perform in-cluster builds. What Bangalore story does that remind me of? I see a lot of people being very vocal about the traffic while they are stuck in traffic itself. So it's like build on. So that's really the Bangalore story that this reminded me of. And so again, you're probably going to see some of this repeat in terms of a theme. But yeah, let's talk tech. You have a Kubernetes cluster. And on that Kubernetes cluster, you can create what is known as a service account. Everybody knows what a service account is, hopefully. If not, you're in the wrong conference. The restaurant is upstairs. Have a nice time and go home. And then you create a primitive known as a cluster store within the Kubernetes cluster. A cluster store is basically, all of this is YAML, but it's basically a definition that allows you to say what your target builds are going to be like. Kpack also requires what is known as a stack to be defined. This creates the base images on top of which you'll be building things. And then there is a life cycle for how the build operation should perform. And then this life cycle is largely governed using cloud-native Buildpacks. Now, there is a builder that sort of orchestrates or brings together all of these primitives. Sorry if it's a little rushed. I'll show you a little bit on the command line, which will help you understand better. And this combination of these 4 entities is what is known as kpack itself. So these will all run as individual CRDs on your cluster. The reason for doing this is you're taking a lot of advantage using Kubernetes, right? So you have that kind of reliability. It's very convenient to manage. All of it is declarative infrastructure, blah, blah, blah. The idea behind using kpack is you take all of these advantages and apply it to your build process as well. Why do you want that to run on a Jenkins monolith while your application itself enjoys Kubernetes privileges, right? So that's the reason. Coming back to this, you define an image that you want to build in yet another YAML, And then kpack will pull that YAML, or when it is applied, it will take that up, run it through the builder, and then it's capable of uploading that image that it has built to a container registry. We all love different container registries, Docker Hub. But I'm going to pretend that I know Harbor and I like it because it's a KCD event. So irrespective of what container registry you use, you're going to be able to get kpack to function with that. And this is sort of the life cycle that it operates in. And again, it uses cloud native Buildpacks under the hood, which is sort of the hidden gem inside this hidden gem. I think Buildpacks is a bit underrated for what it's capable of. I really recommend folks try that out. Nimi this morning said something very interesting. And so every bit of this theory that I'm going to preface stuff with, I'm actually going to show code. So I do have some demo examples prepared for all of the things that I'm going to show. And so if you love YAML, there's a lot you can go through. And each of these define different things here. So like I said, there is a stack which will define your base images for what needs to run and what you'll use for build. There's the cluster store, which basically defines what applications you're going to build and what build packs you're going to use for those applications. There is the life cycle that I spoke about, which basically says make use of the Buildpacks life cycle. I've kept it extremely simple. You can customize this in 100 different ways. We're not going to go into it because there's just 18 minutes left. And so how do you apply? You make a deployment is you apply using a typical YAML. And so when I do that, if I switch to my Kubernetes cluster, at some point you will see a build pod come up. So I ran these in the morning so that I don't fall flat on stage. And hotel Wi-Fi is extremely good. Conference Wi-Fi can be very reliable. So this is like a Java application. I love Java. A lot of the internet runs on Java. I don't care what you think. I'm not a TypeScript hipster. It basically takes this repo, runs the cloud native Buildpack lifecycle on it, and then it'll, if you notice, there's none of that Spring stuff that comes up because this is just concerned with the build process. So it'll run the build, and then it'll leave the image for purposes of this example on my Docker Hub. So if I go to hub.docker.com and open my Docker Hub, whatever you call that, like I said, hotel Wi-Fi, extremely reliable. It'll actually show you that this build is available here. So kpack will build it on a cluster and put it on a container registry. So if you have a CI/CD system that does a build and puts it on a container registry, I highly recommend using kpack. So like I said, this ran about 4 hours ago. It will soon update with the build that we just kicked off. But I think we're past that for now. My next project that I wanted to showcase is Ratify. You've all heard of, let's see, you all heard of software supply chain security problems? Yes, no, maybe? Okay, good. I think everybody should sort of take stock of what that is. We're all consumers of open source here. We're all contributors to open source as well, hopefully. So understanding that open source can create problems downstream is extremely important as engineers who consume open source and as contributors and maintainers and all that. And one of the ways in which people have, or the community has come together, is to try and introduce what are known as provenance and attestation to artifacts. I don't know what those mean exactly, neither does the community, but we're all figuring it out, right? That's the beauty of open source. So basically the idea is, it's like a Twitter blue tick verification stuff, right? Everybody knows that. So the way Ratify operates is it works with existing CNCF projects that are all somewhat in the same space. And then it will introduce what are known as signatures and attestations that are either through projects that exist or ways in which you manage to already do, and then it will do some admission control and gatekeeping when you're trying to deploy this, okay? So it will help you verify the authenticity of the artifacts and say with confidence that this artifact originated through this organization or through this person and therefore is trustworthy. It basically, like, again, it has 3 or 4 different pieces. There is signatures that are created elsewhere, there are admission policies that are created elsewhere, and there's Ratify that sort of brings all of these together. And I know the question on your mind is, Ram, we've heard the story before, but what's the difference between Ratify and cosign and OPA, Gatekeeper, and Kyverno? And I know the Kyverno people's antennas will really go up when I start the Ratify story, because that's just how they are. You know what that reminds me of in Bangalore? CTR, Vidyarthi Bhavana, MTR. There's a perennial debate about which dosa is better, and then once you're like 30 minutes into this discussion and you're already very hungry, somebody will come and say, Maga Mahalakshmi room, best dosa, right? I have a fan there. So that's what this debate reminds me of. Now, granted that these 4 projects have a lot of overlapping features, but there's some tiny distinctions between all of these, and I'll try to identify what those are within the next 30 seconds. So cosign is basically a project that does actual signatures and what are known as attestations. OPA is a slightly older project that does admission control and gatekeeping, and Kyverno is a more recent project that also does admission control and gatekeeping. And Ratify is a more recent project that also does admission control and gate. So basically, it's all masala dosa. Let's not fight over it. But they all come from slightly different pedigrees. OPA takes a more neutral approach and does just policy and admission, whereas Kyverno goes the extra mile of adding a lot of governance layers, etc. And Ratify originated from a slightly different project known as Notary. So if you know the Notary project, Ratify is basically built for consuming Notary, and it closely ties in and operates well with the other projects. I don't know how Ratify plays with Kyverno yet because I've not had time to experiment that. Maybe that will be my next year's talk. Anyhow, again, show me the demo. So we're talking about Ratify here. I'll make this demo very quick. The first part is going to be, hopefully you can see this at the bottom, but it's no big deal. The way Ratify works is you set up some CRDs on your Kubernetes cluster, and then you see all these gatekeeper controllers. These CRDs in this namespace, all of those are for Ratify. So there's the Ratify controller along with the gatekeeping and the policy, admission, all of those engines. Okay, so now I'm going to deploy a signed image, and here this is an example of a pod that we just deployed that has a signature in it. So if you check the image, it will show you that there is a signature, and it's basically this dummy container image that I was just trying to deploy here. And then you can try the same by deploying an image that is not signed. Obviously, it will say, screw you, I'm not going to deploy that. Okay. So basically, the gatekeeper will deny this request because it failed to show a signature. So you can create a system where you're only deploying signed images. And why is that important? Signed images cannot just come from an individual user or an individual organization. Considering that you have CI/CD infrastructure and you want images that are built only on your build infrastructure to be deployed, you can sign your images saying it came from this build infrastructure. And then during admission, you can say, hey, deploy it only if the signature matches the signature from our build infrastructure. So when you're deploying, so what happens is, I know this is wasting a little time, but it's very critical, is engineers tend to move fast and break things because it's glamorous, right? So this didn't happen to you, it happened to a friend. What my friend did was he was not able to deploy something, so he copy pasted a couple of layers from a couple of lines from a Docker file on Stack Overflow, and then he just created an image, and then the image got created, and then he deployed it, and then the lines that he copied were pulling a few images from some other sources. You don't do that, right? You're all very careful about your Docker files and stuff. So this friend of mine, so what happened to the image he deployed was it had certain layers inside the container that he built that was already compromised. Thank you. And because those were already compromised, he basically screwed up. And there was a security issue, and then they had trouble narrowing down what the issue was, but it's obvious, right? This doesn't happen to any of us because we are so secure. And so you want to be very careful of what you admit to your production clusters, and this is one way to do it. Maybe a lot of you won't do it, but at least know that you can, and pretend during your performance review that this is what you're going to work on for the next 2 years. Anyhow, next, there's a project known as KitOps, and KitOps is spawning like a handful of different projects. And welcome to the AI flavor of the different hidden gems. And if I don't talk about AI, I don't think I'll be invited for next year. So I thought I'll throw in like an AI thing in this talk. So there is a CNCF repo called Model Spec. And what they're trying to do with that is they're trying to define what is the format in which models and all of this inference infrastructure that you're all going to use on your own production systems should look like. Now, there is AI, and then there's cloud native, and then for some reason, these two communities decide to be joined in the hip. And then now, as an infrastructure person, it's extremely hard for me to catch up with all the AI news. And it's hard for the data scientists with PhDs and who work with Python to understand what this Docker and Kubernetes and containers and all this nonsense is. And so both of the communities are somehow a little unhappy. And so this is a project that I think will make a lot of people very happy. So the reason this is so popular right now is there's a lot of confusion about where cloud native stops and where AI begins, and should these be two very distinct things, and should these be very different things? But from what I infer is this community around KitOps is trying to do for the AI world what Docker did with containers. And so I've been working with Kubernetes for a while now, and then I thought Kubernetes is so complex and people do so many different things, it's hard to unify them. Until I discovered what's happening in the AI ML world. It's very glamorous. They call it ML ops, and you're paid a shit ton of money to work on those problems, but it's garbage. It's unimaginable, all of the kind of, it's like everything is happening at once and everybody is trying to go in different directions. And where have we seen this? Oh, I know, Silkboard. And I was mentioning this to somebody, and somebody said, no, try Hebbal. That's even worse. I said, that's not something to be proud of, right? And then if you look at it, a lot of code in the ML world lives hidden inside Jupyter notebooks between data calls, okay? There's also some code that lives in Git repos, which is how it should be. And then there's some data in data volumes that are external. But also some geniuses decided to put some data in S3 buckets because we have an AWS account and we have a lot of private equity money, so why not, right? AWS bills are an engineer's best friend. And then there's also like some technical debt from the CTO who resigned 2 years ago, who decided that no, this will be the most opinionated way. And then there's so many configs that are hidden inside so many different things. It's just, the more you remove layers, the more keep coming. And then there's also these things called pipeline definitions that I once found in a Google Docs that had to be copy-pasted every time you wanted to run something. So it's a mad, mad world. And considering the history of where we have come from and where we are trying to go, it's extremely relevant as a problem to be solved. And I think people are in the right space with this KitOps and all of these other open model specs that are trying to define, here's what a model should be, etc. So I'm going to emphasize that. No time for emphasis today. We're going to have to very quickly So I'm just going to show you how they're structuring it. I'm not going to run anything because it takes ages for any of these things. So they're creating what is known as a kit file. If this does not scream copy pasting Docker file, I guess imitation is the best form of flattery, but whatever. So there's a kit file that basically defines what your end container is going to look like. And then there's a model, I guess, of something there, llama, blah, blah, blah. And then you can basically pack, so the kit file defines how you want to package and push this model. You can do very interesting things with GitOps and this cloud model, cloud AI model specification. And the way you go about it is you basically define what you want your end container to look like, and the kit, which is like the CLI, will basically help you pack things and export them as a container so you can deploy easily to cloud native infrastructure. Headlamp. All of this is fun until it's not, because let's face it, we're all engineers and we love ugly interfaces like that. But sometimes we like to dress up for parties, for conferences, etc. And it's not too bad to like find a UI and try to make it work. It's not going to make you less of an engineer. So for those who are not aware, there is a nice UI for Kubernetes. It's called Headlamp. Okay, there's a big Microsoft team that works with Headlamp, and I'm going to. It runs as a pod on my Kubernetes cluster. So if you look here, this is basically the Headlamp pod. It's running since morning, I guess. But it basically allows you to throw a very clean UI on top of Kubernetes. So for purposes of this demo, I'm using a very shitty port forward, but you can have something that's more sophisticated and things. So basically, in my opinion, a very useful way to understand what's running in any cluster. It gives you a lot of information about what the pods are doing in your cluster. If you want it drilled down by different pods, by different deployments, etc., it can do that for you. One of the things I like is it will break down all custom resources, so I know exactly what's running. So if you look at some of these, it reflects, all of the different kpack stuff, all of the different things. So looking at kpack things like this, in my opinion, is extremely useful than looking at some CLI with God knows what. Same goes for the ratify stuff and things like that. So it's a very useful UI, in my opinion, to try on your Kubernetes cluster if you don't already have a UI working there. Last 2 minutes, last couple of projects. There's Kraken. Kraken is amazing. When I had first posted about doing this talk, somebody said you should do Litmus Chaos. Litmus Chaos has like 6,000 GitHub stars. So screw you, Litmus Chaos. You're very useful, but I think Kraken is an up-and-coming thing. It's a Red Hat project. The sponsors, I think we should do a little for them. But also, Kraken, great project. It does not run in cluster, but it helps you test your Kubernetes cluster. So they have like a bunch of different ways in which they do toolkits. And why is chaos testing important? We all know that there's tons and tons of engineering work that goes into building something useful, even if in software. And if you're not testing properly, you'll end up with a lot of problems. So always test before you deploy. Always proofread your copy before you print. Right? So it's that kind of thing. I'm not going to show a demo, sorry. 1 minute left. And then this is the most recent project that I found that is extremely useful. I am a bit of a security nut, and I love projects in the security space. There is Spiffy and Spire projects inside the CNCF that have done phenomenal in the areas of identity. Tokenetes builds on top of Spiffy and Spire. And Tokenetes basically helps you make use of identities from Spire, which is an implementation of the Spiffy specification. And this project is basically, it will sit inside your microservices, help you federate identities, verify them, etc. It's very useful. Identity is sort of the building block on which RBAC is built, which is what Kubernetes is all about. And like I said, it's built on these very foundational CNCF projects that have shown a lot of promise. No time for an architecture diagram, but only 6 blocks. You can process this yourself. Absolutely no time for an ugly YAML, so let's skip that. In terms of a demo, nothing left. I know 6 projects, and I know time's up, but just one last thing. KubeCon India, don't forget to register. If you like one day of this, it's 2 days of that. It's going to be extremely fun. And if you don't know, the KubeCon co-chair is sitting right here. Say hi, Atul. Yes, so if you have any questions, you can ask him. You'll find him hanging around here, taking pictures of his food, something like that. That's what he mostly does. But before the day KubeCon India is happening, this is an inaugural open source summit, which is a flagship Linux Foundation event. So if you like open source work, if you are a contributor, if you're a maintainer, if you want to be a contributor in future, I highly recommend adding that event to your calendar as well. It's the day before KubeCon, easy to remember. Nice, fun time to spend a whole day. I think the food will be good, so it's definitely worth if you're. But this is not my one more thing. My one more thing was OpenSSF Community Day. This is sort of my event. So I help bring a lot of security stuff around open source in India. There's some phenomenal talks that are there. If you like Kubernetes, and if you like open source stuff, I think the important thing is to prioritize security, and this is happening on the day before Open Source Summit. So 2 days before KubeCon, so the whole day is focused on security conversations in open source. Again, it's just totally worth it just for coming for the lunch, okay? So I really hope to see a lot of you there. Please get tickets if you haven't. Just a reminder, please contribute. A lot of the projects that you saw today are very small, very fledgling. Yes, it has names like Microsoft and Red Hat attached to it, but the documentation sucks for a lot of them. I don't want to be out loud and offend people, but it does suck. So even if you can just contribute documentation or proofread some of the copy that's there, and if you can do something to help better the ecosystem, I highly recommend doing it. So that was my big talk. Hopefully it was like a nice Uttar Karnataka, Bengaluru meals for you. And this is me on social media. Please give me a follow. Thank you so much for having me this year, KCD Bangalore, and thank you all so much for attending.
Thanks.